Okay, everyone. So today our topic is related to factorization, and it is divided into two portions. So basically, there is something called factorization, and there is something called expansion. But we'll be focusing primarily on factorization today, and if we have a lot of time, we can continue with expansion. Okay. So, for example, there is an expression in the form of x plus y whole squared. We all know one thing for a fact, as we learnt in the rule of indices, and that is that whenever we have x plus y whole squared, it can also be written as x plus y multiplied by x plus y, right? So when two x's are multiplied with each other, we get x squared, and when x is multiplied by y, we'll get xy, and then y is multiplied by x, we get xy, and then y is multiplied by y, we get y squared, right? So the overall final answer that we will have is x squared plus 2xy plus y squared, right? This is the final answer that we have. This terminology is called expansion of brackets, of quadratic brackets. Expansion of quadr quadratic brackets. Now, what do I mean by that? Now, imagine that we have some sort of an expression in the form of 4 plus 3 whole squared. Now, this can be done in two ways. Firstly, what we can do is, if we follow the BODMAS rule of brackets, order, division, multiplication, addition, and subtraction, we know one thing for a fact that if we write b first, if we solve b first, which is bracket, we must be solving this as 7 squared equals 49, right? But if we solve this individually, we can also write this as 4 plus 3 multiplied by 4 plus 3. 4 will be multiplied by 4, giving us 16. Then 4 will be multiplied by 3, giving us 12. Then 3 will be multiplied by 4, giving us 12. And 4 multiplied by 3, finally, giving us 9. So if we add all of this, this is 28 plus 21, which gives us the answer of 49. Hence, we can prove this in the form of bases when they are in the form of constants like x and y, right? So there are generally this is associated with this idea that we have two terms in which they must be taken common first of all, and then we are going to be performing various steps. So now let's have a look further. Can I erase everything? Okay, that's great. Let's move. Okay, so for example, we have an expression of 4x minus 12, right? We have this expression. There are two steps that we need to do. First of all, we have to take common using division, and the next step is use the formula of a square minus b square equals a plus b, a minus b. Now, from where did we get this formula? Let's multiply a plus b and a minus b together, should we? If we multiply both of them, what do we get? A squared minus ab plus ab, b into minus b is minus b squared. Minus and plus are going to cancel out, they neutralize each other, and as a result we get a square minus b square, right? Are we understanding this? Okay. Yes. So this is how we are supposed to do it. So as simple as that. Now in the first few questions that I'm going to solve, we're not going to be using this. So let's just keep this portion aside. I want you to factorize this. What can we get? If we take 2 common, okay, let's take 2 common for instance. This will be written as 2x minus 12, 2x minus 6. But think again. Can we take a common again? Absolutely. 4 will be taken as common, and this can be written as x minus 3. Right? Okay. Let's take another example. 5x squared minus 25. What can be taken as common? Yes, 5. Can we take x squared common? No, we cannot, because x squared, any mode of x is not present here. So we cannot take x squared as common, right? 5x squared minus 5, because if we multiply 5 by x, we get 5x squared, and if we multiply 5 by minus 5, we get minus 25, right? So it is working both ways, right? Okay, now let's twist the question a bit. 6x squared plus 36x. Now what we will take as common? Any ideas? Okay, according to you, we will take 6 as common. Let's solve it. 6x squared plus 36x. Think again. Can we take something else as? No, we won't take x squared as common, because x squared is not present here, and but x squared is present here, but it's not present here, right? There is no x squared here. There is only x. Yes, we'll take x as the common one along with 6. So it will be written as 6x x plus 36, right? Because if we have to take the minimum sort of a common. One more example. 7x squared minus 63x. Any ideas? Good. Yes. So 7x as the common, x minus 9. Great job. Okay, so now we understand how we shall take commons, right? Okay, let me give you a difficult example. Let's say we have 4xy cube plus 16x cube y. What do we have here? What should be taken as common? Let me just rewrite it a bit so that you can understand it well. 16x cube y. Yes, Ayan. Yes, you're right. We'll take 4xy as common. Why? Because we have x cube here, but we don't have x cube here, right? We only have x. So x cube can also be written as x times x times x. Am I right? So we have x present here as well. Just like that, y cube can also be written as y times y times y. Am I right? Yes, absolutely, you're right. So this can be written as 4xy. That will be common. Now be careful. What will we have here? No, we won't have 4x. We'll have y squared. Yes, Arisha is right. We'll have y squared, right? We'll have y squared here, and then we'll divide 16 by 4. What's 16 divided by 4? 4. Yes, x cube. Well done. So are we understanding this as of yet? Great, great, great. Okay. Shall I erase all of this? Okay, great. Then we have an idea of middle term breaking. And this brings us to quadratic equations, or with three terms. Now we know one thing for a fact. What is a quadratic equation? Can any one of you tell me? Yes, Ayan. Oh no, it has got nothing to do with four terms. It can have four terms, but it has got nothing to do with having four terms. No, acha, he was thinking that quadratic is derived by the word quad, which means four. No, 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 no. Quadratic equations are those types of equations that have highest power degree of 2. Degree of 2. So it could be, let's say, 5x squared plus 25x plus 36. So what's the highest power degree here? It's 2. This is 1, and this is of course 0, right? And if I say, let's say 6x squared plus 39, so I have x squared. If I have 7x cubed plus 3x squared plus 12, is it a quadratic equation? Yes, no, it won't be, because the highest power degree in this case is 3. So this is referred to as a cubic equation. So, but just leave it right now. We don't need to know what is a cubic equation. Just remember that a quadratic equation is an equation that has a highest power degree of 2. Okay? Okay, let's continue. Imagine we have an equation x squared plus 7x plus 12. Now we have three terms. I want you to find values of x such that x satisfies the equation. Now what do we mean by satisfying the equation? When I mean satisfying the equation, I actually mean find the value of x to this extent that this entire equation equals to 0. Okay, this entire equation equals to 0. Now what do I mean by that? We need to find any two values of x that would help us to reach the final answer of 0. Okay, how do we do this? I want you to make two columns. Okay, now simply the method is very simple. If there, oops, let me just write it better, and let me just write it in black. Simple. If there is no term before x squared, find two numbers that multiply to give c and add or subtract to give b. What do I mean by that? It might be a bit difficult to understand, but any quadratic equation can be written in the form of x squared, ax squared plus bx plus c. Now can we compare these coefficients? We have x squared plus 7x plus 12, right? What do we need to do? We need to find, yes, if there is no term before x squared, is there a term? Do we have a term? Yes, we do have a term. That's 1, but that's negligible, right? So basically, if there is 1 before x squared, find two numbers that multiply to give c. We need to find any two numbers that multiply to give c, but they add, those same two numbers add or subtract to give a b. What are the multiples of 12? 12 times 1 6 times 2, 3 times 4. Any else? No, no, we won't have multiplications. It's not going to be 8 times 1.5. No, Ali, you're wrong. It won't be 8 times 1.5. Sorry, I had to mention your name. It's okay. But it won't be 8 times 1.5 because it's not in a whole number form, right? So out of all of these three types of factors that we have, which one of them would give us an addition or a subtraction of 7? 3 times 4, right? Yes. So we'll select this. Now, in what way are we going to write this? We can write this as, have you written this? Okay, no, in fact, I'll erase this. And let me just make some more space. Yeah. So we have 3 multiplied by 4. What we simply need to do is that we have to add x in in front of them. That gives us a final answer of 7x. What do we mean by that? This can be written as, can I write x squared plus 7x plus 12 in the form of x squared plus 3x plus 4x plus 12? Can I? I can, right? And I can do it, right? Can I write it in this way? Absolutely. So which means now I want to find a common. What's the common here? X. Good. What will be inside the brackets? X plus 3. Well done. We'll close the bracket here. What's the common here? 4. Well done. And what we will put in brackets? X plus 3. Now we have two brackets. One is x plus 3 and the other one is x plus 4. Now I want to ask you one question. A squared minus b squared, are we somewhat writing this in the form of a plus b, a minus b? A plus b, x plus 3. Oh, okay, sorry, it's not that equation. Sorry, I messed it up. Yeah. But are we getting an idea? Okay, okay, no worries. Okay, let's solve another question, should we? Okay. Just remember this rule and let's move forward. Yes, x squared plus 6x minus 16. I want you, now first things first, do we have a term before x squared? No, we don't, right? We don't have any term before x squared, so we'll consider this as 1. Find two numbers that multiply to give c and add or subtract to give me a b. 16 times 1, 8 times 2, 4 times 4. Anything else? No, right? Now, out of all of these terms that I have, which one of them can be considered that if we add or subtract them, we'll get a 6? 8 and 2, right? So can I write x squared plus 6x minus 16 in the form of x squared plus 8x minus 2x minus 16? Because 8 minus 2 is 6, right? Can I? Absolutely can. Okay. We have x as common. Come on. X plus 8, good. Now Ayan will answer. Ayan, what will we take common here? Minus 2, good. Bracket x plus 8 or minus 8? No, it's going to be plus 8. Why? Because when we multiply minus with minus, we'll get a plus. When we multiply minus with minus, we'll get a plus, right? And secondly, we need to have the same value as the first bracket. So we'll have two brackets, x plus 8 and x minus 2. So x plus 8 equals to 0 and x minus 2 equals to 0. So we get x equals to minus 8 and x equals to 2. If any one of you is a football fan, and especially a Real Madrid fan, you will understand what these two numbers are. Anyone? You guys watch football? Yes. It was basically the score line between Barcelona and Bayern Munich, right? In the I think it was 2021 Champions League semi-final or quarter-final, I guess. Yes. Yeah. So if we input the values of minus 8 or 2 in this equation, we will get an answer of 0. Is it? Let's have a look. 2 squared plus 6 times 2 minus 16. What's 2 squared? 4. Plus 12 minus 16. 16 minus 16. Are we getting 0? Yes, we are. Okay. We have another example of minus 8. Minus 8 whole square plus 6 into minus 8 minus 16. Minus 8 whole square is 64. 6 into minus 8 is minus 48. This is minus 16. 64 minus 64 equals 0. Understood? Great. Solve another example? Okay, we'll solve another example. For example, we have x squared minus 12x plus 20. Once again, no term before x squared. Find two numbers and multiply to give c and add or subtract to give b. C is 20. We can write it down. A equals 1. B equals minus 12. Be careful. B equals minus 12. C equals 20. I want to have two numbers and multiply to give c and add or subtract to give b. 20 can be written as 2 times 1. It can be written as 10 times 2. It can be written as, what else? 5 times 4. But I want to have those two numbers that add or subtract to give me a 12 or a minus 12. 10 and 2? Absolutely. So we can write x squared minus 12x plus 20 in the form of x squared minus 2x minus 10x, because it's minus 12x, plus 20. What will we have as, what will we have as common? X squared, right? Well done, Ayan. It's x. X minus 2. Good. Minus 10 will be taken as common. X minus 2. Well done, because plus and minus gives you a minus. So we have two brackets, x minus 2 and x minus 10. Okay? Great. So we have factorized these equations. Very well done. Yes, you could have written it that way. X squared minus 10x minus 2x plus 20. Okay, we can solve this as well. We can take x as common, x minus 10. It would have given us the same thing, minus 2, x minus 10. So you see, we have x minus 10 and x minus 2 as well. So it would have been the same thing. So it wouldn't have mattered much. Right? Are we understanding? Should I solve another example or should we move forward? Solve another example. Okay, let's solve one more example and then we can move forward. Okay, here we have x squared minus 2x minus 24. Once again, a equals 1, b equals minus 2, c equals minus 24. Be very careful about the minus signs, okay? Find the factors of 24. 24 times 1, 12 times 2, 8 times 3, 6 times 4, right? I want to have any two numbers that add or subtract to give me minus 2 out of all of these. Now, why would we have 2 and 6? It's supposed to be those two numbers are supposed to belong from the same factors. Okay? Yes, so we can write this as x squared minus 4x no, it's not going to be minus 4x. Yeah, we can write it as plus 4x minus 6x, because plus 4 minus 6 gives us minus 2 minus 24. Can I? I think I can. Let's take common. X plus 2 minus 6. Wait, why do I have 2? Oh, sorry, I just wrote 2 by mistake. It will be written as 4. Right? Minus 6 x plus 4. So I have two brackets, x plus 4 and x minus 6. Very well done. Everything clear so far? Chale, that's great. Okay. Okay, now we have a different scenario. As of yet, we were solving middle term breaking, but we had 3 terms. Now here is a twist. First, write the rule down. If there is a term before a, multiply the a with c and find the value, or in fact no, not the value, find the numbers that add or subtract to give b. Now what do I mean by that? Let's have a look at a different example. For example, this is, we'll end our class on this note. For example, we have 2x squared plus 29x minus 15, right? We have this example for now. Wait, just give me a minute. Okay, so sorry for the disturbance. So we have 2x squared plus 29x minus 15. What do we have to do? If there is a term before a, we have a term before a, which is 2. Multiply the a with c. 29, c equals minus 15, right? We have to multiply a with c. Minus 15 multiplied by 2 gives us minus 30. Find the numbers that add or subtract to give b. Basically, we have to find roots of those numbers that add or subtract to give b. What are... yeah, yes. So, for example, how would we get 30 if we multiply two numbers? 30 times 1, we have 15 times 2, we have 10 times 3, we have 6 times 5, and then 5 and 6 and so on and so forth, right? Now we need to find, yes, two numbers that give us, that add or subtract to give us b. What could be? 30 times 1? Absolutely. So can I write this as 2x squared plus 30x minus 1x minus 15? I can, right? What do we have to take common here? No, we won't take x as common. 2x. 2x, x plus 15. Good. Minus 1 as common, x plus 15. Right? So we have two brackets, x plus 15 and 2x minus 1. Right? So as I told you all, today we won't be studying a lot. This is all that we will be studying today. So any questions from today? Okay. Okay, sure. Sure, you can leave. Okay? Goodbye.